Hi students, welcome to my channel Sri Academy of Physics and this is Dr. Balaji Rambatla. Students, in this channel I would like to post physics videos of level Inter, B.Sc, B.Tech and M.Sc and some of core branch videos also. Please go through my channel for better understanding of subject in simple way and score maximum marks in academics. In my videos, I provide complete notes of the topic and explain in English and in my regional language Telugu for better understanding of the topic. For this, please subscribe my channel Sri Academy of Physics. స్టూడెంట్స్ ఈ వీడియోలో నేను మీకు సోలార్ సెల్ గురించి ఎక్స్ప్లెయిన్ చేస్తాను. దిస్ ఈజ్ వెరీ ఇంపార్టెంట్ క్వశ్చన్ ఫర్ M.Sc students, B.Sc students and B.Tech students also. The question format is like what is solar cell, explain the construction and working of the solar cell and explain about the VA characteristics of the solar cell. Right. Now when we enter to the topic, first solar cell. Solar cell ఏం చేస్తుందమ్మా? Solar cell is nothing but a specially designed PN junction diode. ఏం చేస్తుంది solar cell, which converts the solar energy into electrical energy. ఇది మనందరికీ తెలిసిందే. So solar cell or solar battery is a basically PN junction diode which converts the solar energy into electrical energy. So solar cell is nothing but simply a photodiode and it is operated in zero bias voltage. It is operated in zero bias voltage. So circuit symbol of solar cell ala untundamma. This is a positive terminal and this is the negative, right? And this arrow represents sunlight. This is represents sunlight. This is the symbol of solar cell, right? This is the symbol of the solar cell. This is the positive terminal and this is the negative terminal, right? Now we discuss about the construction of the solar cell. Now we will discuss about the construction of the solar cell. Okay, what is solar cell? Solar cell is a PN junction diode. Generally it is fabricated with germanium or silicon. It may also be constructed with many other semiconducting materials like gallium arsenide, indium arsenide, cadmium arsenide, so on. Nowadays, the solar panels you've prepared with organic polymers. Right. This is the diagram of the construction of the solar cell. సో మీరు ఇక్కడ చూస్తే సోలార్ సెల్ ఏముందమ్మా? పీ టైప్ సెమీ కండక్టర్ పిఎన్ జంక్షన్ డయోడ్ కదా, ఇది పీ టైప్ మెటీరియల్ అండ్ దిస్ ఈస్ ద ఎన్ టైప్ మెటీరియల్, రైట్? ఈ ఎన్ టైప్ మెటీరియల్ కిందన దేర్ ఈజ్ ఎ మెటాలిక్ కాంటాక్ట్. ఇట్ షుడ్ బి యాక్ట్ యాజ్ ఏ క్యాథోడ్. ఇది క్యాథోడ్ కింద యాక్ట్ చేస్తుంది. దీనిపైన ఒక నికిల్ రింగ్ లాంటి నేను ఇన్సర్ట్ చేశాను. ఇట్ షుడ్ బి యాక్ట్ యాజ్ ఏ యానోడ్. అండ్ ఈ నికిల్ రింగ్ పైన దేర్ ఈజ్ ఏ గ్లాస్ విండో. ఆ గ్లాస్ విండో ఏం చేస్తుందమ్మా? ఇట్ అలౌస్ ద సన్లైట్ టు ఇన్సిడెంట్ ఆన్ ద P region and N region. Now this anode and cathode we connected to this is load resistance, right? We are connected to the load resistance. Here we are not using any biasing. So here the PN junction diode we are not connected in forward bias or in reverse bias. So it is a special photodiode, simply a photodiode operated at zero bias voltage. Here load resistance is nothing but it may be a mobile or a geyser, a tube light or something. Okay. Now, when we come to the construction of a solar cell is nothing but a PN junction diode. It is a PN junction diode formed in a pack in a can. So we are the PN junction diode you are placed in a can with a glass window on the top so that the light may fall upon the P and N type material. So PN junction diode you are placed in a can with a glass window on the top so that light may fall upon P and N type materials. So here the light is allowed to incident on the P region as well as N region. For that purpose, we maintain the thickness of the P region is kept very small, right? So the electrons generated in this region can diffuse to the junction before they combine. Right, the thickness of the P region is kept very small so that electrons generated in this region can diffuse to the junction before they recombine. Right, for that purpose you are maintaining the thickness of the P region, it should be very small. Right, now so here the P and N regions are heavily doped regions. The P and N regions are heavily doped regions. That's why the obtained photovoltage is also we will get the recommended value. The nickel plate ring provided around the P layer which act as a positive output terminal. The metal contact at the bottom serves as a negative output terminal. So here this is a nickel ring. This nickel ring, it should be act as a positive terminal, and the metal contact at the bottom, it is served as a negative output. The positive terminal and the negative terminal, we are connected to the load resistor. We are connected to the load resistor. Right. So here the P and N regions which are heavily doped regions. This is the working part, the construction part of the solar cell. Now here we discuss the working of the solar cell. Solar cell లో వర్కింగ్ ఎలా జరుగుతుందంటే, suppose the sunlight which is incident on the P region and N region, it will produce the hole and electrons in P region as well as N region. Now, due to the diffusion, these holes and electrons, they are moving towards the depletion region. And due to the electric field across the depletion region, the holes in the N region are moving towards P region. The electrons in the P region are moving towards N region. So here the holes are moving from N region to P region. That's why this is the direction of the current. Okay. So story loko say when the solar radiation is incident on the cell, the electron and hole pairs are generated in P region as well as N region. Okay. When solar radiation is incident on the cell, electron and hole pairs are generated in P region as well as N region. Right? So when the light is incident on the P region and N region, the holes and electrons are generated in P region as well as in N region. The majority of them cannot recombine in the region. There is the depletion region at the junction due to the electric field. So whenever the light is allowed to incident on this P region and N region, this hole and electrons are reach the depletion region. Due to the electric field across the depletion region, the holes are moving towards the P region, the electrons are moving towards the N region, and there is a current in this direction. Okay, the electrons in the P region are drawn into the N region, and holes in the N region are drawn into the P region. Right. This gives rise to charge accumulation on the two sides of the junction and produce the potential difference, and it is in the order of 0.5 volts. Right. Their flow constitutes minority current which directly proportional to దేని మీద డిపెండ్ అయి ఉంటుందమ్మా illumination and the light exposed surface area. Right. Suppose when the intensity of the radiation is more, the sunlight incident is more, then more number of electron and hole pairs are formed. More number of electron and hole pairs are formed. So here the current value is mainly due to the minority charge carriers. Their flow constitutes the minority current which is directly proportional to the illumination and also depends on the surface being exposed to light. Right. The accumulation of electrons and holes on the two sides of the junction gives rise to open circuit voltage. Suppose the circuit is made with silicon, this value is around 0.6 volts. And in this case, the short circuit current is around 40 milliamperes per centimeter square. Suppose the circuit you are making to open at this point. Suppose the circuit you are making open at this point. The voltage across this point is called open circuit voltage, and in this situation, the current value should be equal to 0. Suppose the circuit you are making to short circuit. You are connecting like this. This is making short circuit. Then the maximum current is flowing through this solar cell. That maximum current is called short circuit current. Okay. So suppose this diode we are fabricated with silicon. This open circuit voltage is around 0.6 volts and this saturation current is around 40 milliamperes per centimeter square at bright noon sunlight. మిట్ట మధ్యాహ్నం నేను మెజర్ చేసినప్పుడు నాకు షార్ట్ సర్క్యూట్ కరెంట్ ఎంత వచ్చిందమ్మా 40 మిల్లీ ఆంపియర్స్ అండ్ ఓపెన్ సర్క్యూట్ వోల్టేజ్ ఎంత వచ్చింది 0.6 వోల్ట్స్. రైట్. కాబట్టి మనకి కరెంట్ వాల్యూ ఎవరి మీద డిపెండ్ అయి ఉంది? ఇట్ ఈస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు సన్లైట్. ఎంత సన్లైట్ వచ్చి పడింది ఇంటెన్సిటీ మీద డిపెండ్ అయి ఉంది, ఏరియా ఆఫ్ ద ఎక్స్పోజింగ్ మీద డిపెండ్ అయి ఉంది. నెక్స్ట్, ద ఎఫిషియన్సీ ఆఫ్ ద సోలార్ సెల్ ఈజ్ అరౌండ్ 15%. The efficiency of the solar cell is around 15%. Many such solar cells are interconnected to provide the large quantity of the electric power. ఇలాంటి నెంబర్ ఆఫ్ సోలార్ సెల్స్ ని యు ఆర్ ఇంటర్కనెక్టెడ్ చేస్తే it will produce the large quantities of the solar power. This is the band energy diagram. This is the band energy diagram of solar cell. This is the P region, right? And this is the N region. Suppose the sunlight, which is allowed to incident on the P region as well as N region, it produce holes and electrons. Here also it produce holes and electrons. Now what happens? The holes in the P region are moving towards the holes in the N region are moving towards the P region. The electrons in the P region are moving towards the N region. And here there is some current. Right. Suppose when we draw a graph, voltage versus current, the graph appears like this. At different intensities. This is at 50 milliwatts per meter square of sunlight intensity, and this is 100 milliwatts per meter square. This is 150 milliwatts per meter square. The graph is appears like this. The graph is appears like this. This is the characteristic curve of solar cell. Actually, which is comes under the fourth coordinate. Right. It may be seen that 100 milliwatts per centimeter square illumination, the open circuit voltage is 0.57 volts, and the current value is equal to 50 milliamperes. So this value is equal to 0.57, and for 100 milliwatts per centimeter square, this value is around 50 milliamperes. Next, the maximum power output is obtained when the cell is operated at any of the curve. Now, for example, this is the, now we discuss about the efficiency of the solar cell. The efficiency of the solar cell mainly depends upon three parameters. One is short circuit current. Second one is open circuit voltage. And third one is fill factor. So these three are very important parameters to calculate the efficiency of the solar cell. Fill factor is measures the squareness of the IV curve. Now, what is meant by the squareness of the IV curve? For example, suppose when we draw a graph, right? This is the current and this is the voltage. The graph is appears like this. So at this point, and the current value is equal to 0. The current is 0, then voltage is called open circuit voltage. And here the voltage is 0. It means that current is called short circuit current. Right. Suppose when you construct a square or a rectangle like this, the area of this square we can represent it as VOC into IS. And power, we know that power is equal to, what is the formula for power? V into I. So the area under this, the area of this curve represents the power of the solar cell. Suppose when we consider a square at here, the area of the square, it should be represents the power. Suppose when you take the curve like this, the area of this curve, it should be represents the power at some other value. This is the power at some other. Suppose when you take different areas, but at a particular different squares, but at a particular square, the area is maximum. So at the situation, at this voltage and current, at this voltage and current, at this voltage and current, the solar cell which is having maximum power. So that square we are placed inside a IV curve. It should be called fill factor. So at fill factor, the power of the solar cell, it should be maximum. Now, how to define the fill factor value? Fill factor is nothing but it is the area of the square by area of the curve. What is meant by area of the square? That is nothing but Vm into Im, right? What is the area of the curve? VOC into IS. But this value is more than this. That's why the fill factor value is always less than 1. And this value generally which lies in between 0.6 and 0.8. 0.6 and 0.8. The efficiency of the solar cell eta is equal to P out by P in. This is the formula. What is P out? The maximum power. What is the maximum power? Vm Im by P in. But according to fill factor formula, what is VMIM value? That can be written as A. This is equal to eta is equal to A. Here I FF fill factor into VOC IS by PN and రాయచ్చా. సో ఈ రకంగా ఎఫిషియన్సీ ఆఫ్ ద సోలార్ సెల్ ఎవరి మీద డిపెండ్ అయి ఉంది? ఫిల్ ఫ్యాక్టర్ మీద, విఓసి మీద, ఐఎస్ మీద డిపెండ్ అయి ఉంది. ద ఎఫిషియన్సీ ఆఫ్ ద సోలార్ సెల్ ఈజ్ అరౌండ్ 15%, and many such cells are interconnected to provide the large quantity of the solar power. Thank you.